in this orientation here, what's happening is we're turning our head to the left. So this is our right horizontal canal or left horizontal canal. So we have these canals in here, we turn our head to the left, but I'm gonna use this as just a general principle of how our eyes adapt. So we have our vestibular nuclei, they're connected to all of our nuclei for our ocular muscles as well. So then what happens is when we turn our head to the left, our eyes reflexively go in the opposite direction. So this is perfect, should be perfectly connected. This is a vestibulo-ocular reflex, which we're gonna talk about, but we also have the same thing when our head translates horizontally, our eyes slightly roll and compensate for that. So no matter where we move, we get this input from our vestibular system, but then what should happen is our eyes should perfectly compensate for that. Because all three of these systems develop together. Our eyes, our vestibular system, and our neck muscles, they all develop in what's called the homologous column. So they all develop together. So if I have activity of my vestibular system from moving, my eyes should perfectly compensate for that. My neck muscles should perfectly compensate for that. So if we have a cervical dysfunction, that's gonna affect our vestibular system. It's also gonna affect our eyes. So knowing that is really important in this whole mechanism. But I just wanted to simply show you, when we turn our head to the left, we activate different nuclei in the vestibular system. They fire into our ocular nuclei, and then they create an appropriate response of the eyes. So that's just a simple understanding there.